Hi everyone, welcome to Cloud Computing series. Today we'll start from Multicore CPU and Manycore GPU architectures. So Multicore CPUs. Multicore CPUs are expected to increase from tens to hundreds of cores in the future. See, modern CPUs have a multiple cores, like having a many small processors in one chip. Yes, in the future they may have hundreds of cores. Then they are great at running multiple tasks at once, that is parallelism, but struggle with handling a huge amounts of data efficiently. It's called the memory wall problem. Next is, most modern CPUs use 32-bit or a 64-bit instruction sets commonly seen in x86 processors. Next point is many core GPUs. See, to solve CPU limitations, many core GPUs were developed, yes, with hundreds of lightweight cores. See, these are used in high performance computing and high throughput computing for heavy parallel processing. Next is, see, GPUs are now common in supercomputers and large data clusters to speed up data processing. This next point is industry trends. See, many old RISC processors, that is reduced instruction set computer processors, are being replaced by multi-core x86 processors and many core GPUs. See, upgraded x86 processors are becoming popular in data centers and supercomputers. Then next is, the trend is to combine both CPU cores and GPU cores on a single chip to maximize performance. The next is future prospects. See, combining a CPU and GPU cores on a single chip will make systems faster and better at handling lots of data at the same time. See, these architectures are perfect for data intensive and parallel computing tasks. Yes, moving to the next topic, that is multi-threading technology. Yes, multithreading means allowing a processor to work on a multiple tasks or a threads at the same time. Then it helps keep the processor busy and efficient even when some tasks are waiting for data. Yes. Next is, see, this diagram shows different ways modern CPU processors handle multiple threads using multi-threading and multi-core technologies. It compares 5 architectures over a time. Then the first one is 4-issue superscalar processor that handles 4 tasks at once per cycle. Then second one is fine-grained multi-threaded processor that switches between 2 to 4 tasks quickly. Then third one is coarse-grained multi-threaded processor that switches tasks less often when one waits. Yes. Then fourth one is dual-core processor that uses 2 cores to split tasks, as we can see in the diagram. Then fifth one is simultaneous multi-threaded processor that runs multiple tasks at the same time on one core. Yes, see, in this each box represents a cycle with shaded areas showing active threads and blank areas showing idle time. Yes, these methods help CPUs work faster and more efficiently. Moving to the next, so types of processors, as we have seen in the diagram. This works with a one thread at a time and it has 4 functional units to process instructions. Then this is good for simple tasks but not great for multitasking. Then second type is fine-grained multi-threaded processor. It switches between different threads every cycle. Then it is useful when there are frequent changes between threads. Then the third one is coarse-grained multi-threaded processor. See, it works on one thread for a long time before switching. The next is, then it is suitable when switching threads is time consuming. This next is dual core chip multiprocessor. See, it has 2 processing cores, each able to handle tasks independently, and it is good at running 2 different tasks at once. Then the last one is simultaneous multithreading processor. Yes, it can process instructions from different threads at the same time, and this maximizes performance and efficiency. Moving to the next point, that is instruction scheduling patterns. See, different patterns show how instructions from multiple threads are being processed. See, blank squares indicate ideal time, meaning the processor is not doing useful work. Then the goal is to reduce these blank squares to increase performance by improving both instruction level parallelism and thread level parallelism. Instruction level parallelism means handling of multiple instructions at once. Then thread level parallelism means handling of multiple threads at once. Then next is key takeaway. See, efficient multithreading reduces ideal time and increases performance. See, simultaneous multithreading processor is the best technique because it handles multiple threads simultaneously. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe for more insight on cloud computing. Also check out our playlist for more in-depth topics. See you in the next video. Thank you.